Hello. I am making a video here about our first free response question that we had. It's question from the year 2022, number one, the calculator question. And I have pulled up here the scoring guidelines for the question. And I wanted to go through the scoring guidelines as well as give you some calculator tips. Okay. So, on the scoring guidelines, it gives you the question there. From 5 a.m. to 10 a.m., the rate at which the vehicles arrive at a certain toll plaza is given by blah, where t is the number of hours after 5 a.m. So, in the case of a calculator question, the function that they give you is probably going to be used at least two or three times throughout the question. So, calculator tip number one, I've got a calculator pulled up here. You can type you can type out a function and save it for use later. So what do I mean by that? So the function in the question is 450 times the square root of sine of 0.62t, close the parenthesis, right? That's the function. You are probably going to use that at least three times, like I said. So if you look here, I hope this is legible here. Let me maybe make this even bigger, right, to kind of blow this up. Above VAR is the letter STO for store. So if you do control and then click var, it creates this arrow. And what you're telling the calculator is that, all right, what I've typed, I want to store it, and what should we store it as? Why not store it as A of t? And it's going to say done. So at any point now, if you type A of t, the calculator is going to remember what A of t is. Your calculator now knows that A of t is this. So I haven't really solved any of the questions yet, but that takes but 15 seconds to do. And now you don't have to type this over and over. You typed it once and you never have to type it again. So hopefully that is sort of like that seems useful. I sure hope you think that's useful. Okay. So now let's approach the first question. It says to write but not evaluate, meaning we don't have to plug it into a calculator, an integral expression that gives the total number of vehicles that arrive. So, um, hopefully you recall. I'm just going to say this out loud and you can kind of take notes with me if you want. But the integral of a rate gives you a total. Well, specifically the absolute value. The integral of the absolute value of a rate gives you total. So a simple example would be like in our particle questions with acceleration, velocity, and distance. The integral of the absolute value of velocity was giving us the total distance that the particle traveled. Hopefully you remember that. And why the distinction for the absolute value? Well, if you got rid of the absolute value, the integral of velocity was displacement. So there's a difference between total distance versus like the displacement, if you recall, right? So we want the total number of vehicles. So we are integrating this function a of t from 1 to 5. And this is the right answer. And you might be saying, well, it doesn't have an absolute value on it. Well, that's because this answer is always going to be positive because it's a square root, right? 450 times the square root. The square root is a positive function. So there is no chance that it'll be negative. So it actually doesn't matter in this context. But alas, the integral of a rate is total. And this is the rate at which the cars enter the plaza. So if we integrate it, the result will be the total number of cars that entered the plaza. All right, moving on. Question or part B says find the average value of the rate. So our formula for average value is integral of rate divided by the distance between the bounds. And I could probably do a super quick Google search for that. Average rate calculus formula. Average value, not average rate, sorry. Average value. Boom, this one right here. Okay? This one right here at the top. Ignore the thing at the bottom. This thing right here. That is what we want. So we are taking the integral from the previous answer and multiplying it by 1 over 5 minus 1 because that's b minus a, the top bound minus the bottom bound. So let's find the average value of the rate. So this needs to go into a calculator now. So let's do that. All right. So recall we've already got the function a of t saved. So if we open up our so now let's go into the calculator, calculus functions. So if you click menu and then click the number 4, that's going to choose calculus, and then click the number 3, and that's going to choose your integral. So I'll do that again. All right, let me get rid of this. So menu, you can see calculus is in the menu. So if you click the number 4, it'll choose, oops. Right, it was getting confused because of my mouse. And then I do integral. It's getting a little confused because of my mouse. So I apologize. So menu 4 for calculus. You can see it opens up that menu, and then 3 for integral. So our bottom bound was 1. The top bound was 5. And then again, I don't have to type out a of t. I can just type a of t. I don't have to type out the literal function because I've saved this in the calculator. This is with respect to t. And then in front of the integral, I didn't type it first, but it's okay. I can click back and type this 1 over 4, right? 5 minus 1 is 4. So click enter, boom, 375.537. And so if you look at the answer key, there is a point for like using the proper units. So the average rate at which the vehicles arrive at the toll plaza is boom, right? So having the number isn't enough. Stating the sentence with proper units is what we want. Okay. And a good rule of thumb is just taking their words and spitting them back out at them, right? It asks you to find the average value of the rate in vehicles per hour at which vehicles arrive at the toll plaza. So take those words and just say get rid of find, the average rate at which vehicles arrive at the toll plaza from 6 a.m. to 10 a.m. is, right? You just take their words and spit it right back at them and then write the number. Okay, moving on to part C. Hopefully you're feeling somewhat good with the calculator. It's about to get a little hairier with the calculator. So is the rate at which vehicles arrive at the toll plaza at 6 a.m., t equals 1, increasing or decreasing? So you are probably watching this having already been in class. And what I mentioned is that this sheet of all of my lovely suggestions is going to be really useful for you. And when is something increasing? You probably know this. You should already know this. Something is increasing when the slope is positive, aka the derivative is positive. So we need to demonstrate that at t equals 1, let me go down to the scoring guideline, we need to demonstrate that at t equals 1, the derivative is positive. So if we pull up our calculator, we have a of t. Let's derive a of t. So we're going to do menu, calculus and take the derivative with respect to t of a of t. And again, I don't have to type it all the way out. The calculator still knows what a of t is. And I might use this derivative more than once. Wouldn't you say? I might use it more than once. So I'm going to save this. You can choose whatever you want, but I'm going to do Control VAR to get the store, the arrow. And I'm just going to choose the next letter after A, and I'm going to make the derivative B just because it comes after A. So in my brain, that just logically makes sense. I'm going to store it. So what is the derivative? It doesn't actually matter what the derivative is, but spoiler alert, there's the derivative. Okay? But we don't care what the derivative is. What do we care about? We care if the derivative is positive or not. That means increasing. And if it's negative, that means decreasing. So you can see here that the answer, the digit they get is 148. Let's make sure that we get that. So remember, b is the derivative now. So if we take the number 1 and plug it into the derivative, if it's positive, it's increasing. If it's negative, it's decreasing. Oh, that spit out the exact answer. If your calculator does that, you can do Control Enter. Again, Control Enter. Okay. Oh, I think I had to highlight it. Control Enter. Oh, it's because I did B of X. Guys, there's a mistake live. It's because I did X, not T. So let's do that again. So calculus, take the derivative with respect to T of A of T, and I'm going to store it. I'm going to store it as B of T. Sorry, a live mistake. So then if I do B, now that I did T, if I do B of 1, it should give me the right answer. Okay, there we go. B of 1. Sorry about that. There's the 148.947. And because that number is positive, that means that the function is increasing. And it wants you to give a reason. And you must say a prime of 1 is greater than 0. Thus, or however you want to say that, the vehicles are, the rate at which the vehicles arrive is increasing, right? Like that is, it's really important that you say the a prime of 1 is greater than 0 because that is your evidence. You can't say anything else. That's your evidence. Okay. So I hope you're okay with that. Feel free to go back and watch how I hit the buttons for deriving, but hopefully you were able to maybe keep up with me there. The last one, certainly the toughest one, it's 4 points. It's 4 points, so this is certainly the toughest question. A line forms whenever the function that we've been discussing is greater than or equal to 400. The number of vehicles in line at time t between A and 4 is given by this. So this is the number of vehicles in line, where A is the time when a line first begins to form. To the nearest whole number, find the greatest number of vehicles in line at the toll plaza in the time interval. So the greatest number of vehicles, the greatest number of vehicles is them asking for an absolute max. We need a maximum. And as you can see here, the setup, this is the candidates test. And I think we used that name once or twice, but the gist is that you test the beginning and the end of the intervals and the critical points, and by test, we plug them into the function because those are points where where extrema could exist. Extrema can exist at the beginning of the interval, the end of the interval and at any of the critical points in between. And we don't know which one is the most extreme. We don't know which one's the maximum. They're all potential candidates, if you will, and we must test them to see which one is indeed the correct um, value. Okay, so where are they getting these numbers from? Well, what makes a candidate? Like I said, the beginning and the end of the interval, as well as the critical points. And critical points occur when the derivative is zero. Critical points occur when the derivative is zero, or undefined, I suppose, right? So critical points, but there is nothing that's undefined. If you recall, the function involves a square root. There's no way that this is going to be negative because time is positive, okay? So when is it equal to zero, right? When is the derivative equal? So the derivative of what, though? The derivative of n. And n is defined by an integral. So when you take the derivative of an integral, they essentially cancel out, right? So we're canceling out this integral and we're just left with what's inside. The derivative of an integral, deriving an integral, they just cancel each other out and you're just left with what's inside. Except now it's with respect to t. So as you can see here, this right here is really important. This is going to get you a point that you're saying, okay, I know what the derivative is and I'm setting it equal to zero, right? You see this? That's good stuff. So now how are they solving for these answers? Because these are some weird random decimals. All right, let's do it. So in the calculator, new feature here, we're going to do menu and we're going to do algebra 3 and we're going to do solve, which is 1, and we're going to solve. Now, just to demonstrate really quickly, how do we use this feature? Well, what's x plus 2 equals 7? Well, we all know that x equals 5, right? 5 plus 2 is 7. If I punch that in and click enter, it doesn't like it, okay? It says the function or command is missing one or more arguments. You have to type comma x because your calculator is dumb and doesn't know what to solve for. So you say comma solve for x equals 5. That's how the function works, okay? That's how solve works. So menu, algebra, solve. So we want to know when is a of t minus 400 equal to 0? Because we're setting the derivative equal to 0. And what are we solving for? We're solving for t. Now, the calculator is going to tell us something wild. This. And I don't even know exactly what I'm looking at. I'll tell you what you're looking at. If you recall, we're getting a little in the weeds here, but I do kind of want you to understand that a of t involves sine. Sine is periodic in nature, and as it bobs up and down, when you're setting this thing equal to 0, as it bobs up and down, it equals 0 a million times because it just keeps bobbing up and down. So there's an infinite number of answers. We don't want all of the answers. Which answers do we want as this function bobs up and down? We're talking about time. We want the time answers. We want, oops, sorry, wrong page. We want time. And in the question, it says we're bounded between a and 4. We still don't know what a is, but we're bounded between a and 4, and time can't be less than 0, right? So in other words, the smallest a can be is 0. Let's just agree on that. The smallest a can be is 0. So how do we get the calculator to tell us only positive solutions? Well, can we restrict? So the point is we want to restrict t. We want our calculator not to tell us all of the answers, but only the ones we care about. So I'm going to copy this, which, by the way, it's kind of, I can't show you on the screen here because it takes 2 button presses, but you can hit Control, the blue Control, you can hold down Control and then press C to copy. Control C, and then you can Control V to paste, right? So Control and C at the same time will copy, and then Control and V will paste it. You see that? Boom, it pasted it. I guess I could have done it for you. I thought I had to do both at the same time. But you got it? So, how do we restrict our answer? Well, I had to Google this myself. If you see the equal sign over here on the left, if you hit Control and the equal sign, it brings up that menu. We want this one, the vertical bar. And then after the vertical bar, you type the bounds. And what's our bounds? Between 0 and 4. So 0 less than or equal to t, which is less than or equal to 4. And you press enter. Boom. So you're saying, yo, calculator, solve this equation for me, but only give me the t values that are between 0 and 4. And it spits them out for you. I know that's a little in the weeds with the calculator, right? So I want you to feel confident with the math, right? Like the calculator is going to bring you down a little bit right now in this moment, but I want you to feel confident with the math. We took our derivative and set it equal to 0 and solve. That's just what you do for critical points. You know that. And then we're getting a little into the weeds here with the calculator, but we're learning. You're going to get better, I promise. So there's that. So what do we do with these again? We take these values, they are candidates that we plug into the function. And the function here is n. The function here is n. So we're going to take these digits, and you can see how they have these digits written out here, and we're going to plug them in. Now, so A is the 1.4. And without, I guess, diluting this video into me going on into rambles, what we just solved for is the moments that the line starts, right? When a line begins to form. So no line forms before 1.46, okay? So that's why A, the beginning of the interval, is 1.46. That's really important to realize that the A from the problem that was general is what we just solved for. If you don't realize that, you're going to get the question wrong. So A is the 1.46. So maybe I can do some duals. So we're going to take the candidates and plug them into the function. So the function is an integral, which we haven't typed into the calculator yet. We've typed integrals, but we haven't typed this integral. So calculus, which is 4, and then integral, which is 3. And they told us from A to T. But we're not using A and T. We now know that A is 1.46937. And T are the candidates. Right? I know, literally, as I describe this, I'm like, I know there are some of you going like, oh, you're starting to lose me. N of t is not a very pretty function, right? I understand that, but where is this integral? It's the integral. It's just what they told us. N is just what they told us. I'm just taking what's on the page. N could be anything, but you take the candidates and you plug them into the function. You take and the function that they happen to give us is gross. So we know a is 1.46, and where do we plug it into the function? That's key. Where does it go? We're plugging in for t, not x, but t. We're plugging in for t. So t is now 3.59771 because that's one of our candidates that we're testing. And then the function is a of x And I'm able to just type a of x because I defined it in the calculator, minus 400 with respect to x. And when I press enter, I get 71.2541. Boom, the same number that they got. Now, we have to test the beginning and end of the interval as well as the critical points. So we just tested one of the critical points, 3.59771. But we have to test the beginning of the interval and the end of the interval. What's the beginning of the interval? The a value. Wait, so the beginning of the interval is something we have to test? So that means you're solving for an integral whose bottom and top bound are the same. That's just going to give us, I hope you know the answer, 0. You don't need the calculator for that one. And remember, I'm simply highlighting this and doing Control C and then arrowing down and doing Control, arrowing down and doing Control V and pasting it. And then I'm changing the top bound to whatever I want it to be. And the end of the interval is 4. Press enter, and there's that 62.3383. So this last problem has droned on a little bit because, well, I'm teaching you calculator while also reminding you of how to do the problem. So if I can do a 35-second synopsis and then just cold cut this video here. Candidate's test says beginning of the interval, end of the interval, and the critical points. Test them in the function and see which one's the biggest. When you find your biggest, that's the maximum. Well, I just found 71. That was the biggest number. So that's why 71 is the maximum. The greatest number of vehicles in line is 71. Sweet. So to get in the weeds with the calculator, right, I had to take this and solve it for these two values and then take those two values and plug them in. I think the trickiest part of this question, honestly, is probably recognizing that A is the 1.469372. If you don't make A that, you're not going to get these values. And if you mind staring at me in silence, I'm trying to think good explanation for that. So A is the time when a line first begins to form. And I think that's key phrasing. A is the time when a line first begins to form. So a line forms whenever A of t is greater than 400. So A of t is going to be greater than 400. I don't have a terrific way to explain it. Maybe I'll ponder it more. But I think I've shown you a lot with your calculator, and I apologize for being the weirdo who's just like thinking on video. But I hope you learned a lot with your calculator. As I definitely moved quickly with the first 3 questions, then dragged on here. So I hope you learned a lot. Hope you enjoy the rest of your day. Ta ta for now, and I'll